Welcome to the deep dive. Okay, imagine this. Your house generating power, not just when the sun's blazing, but even when it's pouring rain. Sounds a bit strange, doesn't it? Well, today we're diving deep into some really fascinating innovations making that possible. We're looking at how solar panels are being reimagined, focusing on places like Durham, North Carolina, using the great sources you sent over.
It really is remarkable how Durham's become a center for this. They've got this ambitious goal, right? 100% renewable energy by 2050.
That's a big target.
It is. And while they get a lot of sun, maybe 220 days a year, they also average, 46 inches of rain? So finding ways to generate power in all weather isn't just nice to have, it's pretty critical for them.
Okay, so we get solar capturing sunlight. But rain, how does a raindrop actually turn into electricity? What's the key tech here? Our sources mentioned something from China. Triboelectric nanogenerators, 10NG.
Tens, exactly. They're really quite clever. They basically harvest the kinetic energy from the raindrop hitting the surface. It uses a principle called liquid-solid contact electrification. Think of it like a tiny bit of static electricity each time a drop hits.
Static electricity from rain.
Sort of, yeah. And get this. A single droplet hitting just right can generate up to 200 volts. Now, it's a tiny current, microamps, but still, 200 volts.
Wow, okay.
And these TENs are integrated with the regular solar cells. They use an incredibly thin layer of graphene, like 1 atom thick.
1 atom?
Yeah.
Seriously?
Seriously. It helps with the electron exchange, letting the whole hybrid system work in sun and rain. You get maybe up to 6.5% solar efficiency plus the rain power. And you can scale them up, build farms just like traditional solar.
That's a completely different way of thinking about solar. So how is this playing out on the ground in Durham? Are these hybrid systems actually being tested?
They are. Duke Energy has some pilot projects going in the Carolinas. They're pairing standard PV panels with rainwater harvesting systems too. Not just tinges sometimes, but also using the runoff with microturbines.
Microturbines using the rain runoff. Interesting.
Yeah, channeling that rainfall. The output's still experimental, of course, but sources mention seeing up to maybe 1 kilowatt per panel during heavy storms from these combined approaches.
1 kilowatt is not insignificant during a storm. And Durham already has a decent solar base, right?
It does. Over 24.5 megawatts installed. Duke University itself has a pretty big 750 kilowatt array.
Plus, you've got state programs like the Renewable Portfolio Standard and local things like Solarize the Triangle, pushing it forward.
Right. There's definitely momentum.
Yeah.
But it raises the obvious question, what are the roadblocks? What's stopping this from being everywhere?
Good point.
Well, technically, you've got the usual suspects like pollen, dust, general grime that can knock efficiency down 5, maybe 11%?
Like needing to constantly clean them.
Pretty much. Automated cleaning robots are probably going to be essential there.
Okay, so technical fixes exist, but what about the money? That's usually the sticking point, isn't it? Is this tech affordable?
That's the really big hurdle right now, actually. The sources point to upfront costs being about 30% higher for these 10G enhanced panels compared to standard ones.
30% higher. Ouch.
And this is crucial, Duke Energy is changing its net metering rules after 2026. The rate they pay you for extra power you send back to the grid, it's dropping.
How much?
From around 12 cents per kilowatt hour down to just 3 cents. That dramatically changes the payback calculation. We're talking maybe 30 years or more to recoup the investment.
30 years. That basically kills the homeowner incentive, doesn't it?
It makes it much, much tougher. And remember, while a single drop is 200 volts, the power output, the wattage from TENs, is tiny microwatts. So you need a lot of drops, really dense arrays for significant generation.
Okay, so big economic and some technical challenges. But are there bright spots?
Yeah.
Any real-world examples showing promise?
There are. At Duke University, Fire Station 17 has a solar thermal system, and they divert the rain runoff through turbines. It gives them about a 15% boost in winter output.
15% is noticeable. What about homes?
Southern Energy Management in Durham has put in some residential hybrid systems. One example mentioned is a 10-kilowatt system with the Tesla Powerwall and these graphene-coated panels. Apparently, it cut the home's grid dependence by 70% during the spring rains.
70% reduction. That's huge for resilience.
It is. Though on a larger scale, there was that County Durham solar farm approval. It faced some criticism, about lower efficiency in winter versus the carbon goals and concerns about land use. It just shows that even with green tech, you need community buy-in and solid economics right from the start.
Right. It's never just about the technology itself.
Exactly. Looking forward, though, there's exciting stuff in materials science. Self-cleaning coatings, for instance, and perovskite solar cells.
Perovskites, I've heard of those. Higher efficiency.
Potentially much higher, like 33%. But the key thing is they perform better than silicon in low light and cloudy conditions. That makes them a perfect match for this kind of all-weather hybrid approach.
So better cells could make these hybrid systems more viable. What else could help? Policy.
Definitely. Things like revising those net metering rules, maybe using grants from Durham's Clean Energy Fund. They have about $25 million allocated. And just continuing community efforts like expanding Solarize the Triangle or doing demos, maybe at NC State, to get people familiar with it.
So wrapping this all up, what's the takeaway for someone listening? Where does rain-powered solar stand?
Well, it's clearly promising, but still very early days. Think of where traditional solar was maybe 20, 30 years ago. It has real potential to complement what we already have, especially if we get the investment and the policies right. But for right now, the sources suggest that for homeowners looking for reliability and maybe cutting grid dependence, hybrid systems combined with battery storage, that still looks like the most practical path today.
Okay, makes sense. So here's something to think about. What if, in the future, your home's energy wasn't just about catching rays, but could actually harness every single drop of rain? How would that change how you think about being energy independent?